Hello class, welcome to today's lesson. My name is Peter Emisa. Now, before we start the lesson, don't forget to hit the subscribe button to subscribe to my channel. Now, on our previous video, we talked about binary compounds. Now, my main focus right now here is the formation of the ionic compound. That is the types of binary compounds, which is the ionic compounds and the covalent compounds. Now, we started with some examples of the formation of ionic compounds, which leads to the ionic bonding or the electrovalent bonds. Now, I will give you more examples so that you understand the concept very well. So, let's take the next example, which is example 4. So, we are taking calcium and oxygen. So we are to draw the formation of calcium and oxygen using their electronic configuration. So let's do it. Now, calcium. Calcium is having a symbol of Ca on the periodic table. Oxygen is having a symbol of O. O. Now, the next step you should know is the number of calcium, the atomic number of calcium. Now, calcium on the periodic table is element number 20. Oxygen on the periodic table is having a number, atomic number of what? Of 8. Now, the next step is you should know the electronic configuration of calcium and oxygen. So you ask yourself, what is the electronic configuration of calcium? Now, for electronic configuration, we are saying that the first shell should take a 2. The first shell should take 2. The second shell should take 8. Next, 8. So 8, 8, 8. Now, if you are writing the electronic configuration, let's take our calcium here. Now, we are saying that the first shell should take 2. Second shell should take 8. 2 plus 8 is what? 10. How many more is needed to obtain 20? That is 10 more. So next shell should also take what? 8. 2 plus 8 is what? 18. How many more is needed to obtain 20? 2. So this is the electronic configuration of calcium. Electronic configuration of calcium. Now we move to oxygen. Oxygen. Now, oxygen, first shell will take 2. How many more is needed to get 8? That is 6. Now, we are saying that the first element is a metal and the second element is a non-metal. That is why ionic compounds, they contain metals and non-metals. Now, the main aim of this bonding is towards achieve stability or to achieve a stable electronic configuration. Now, for this bonding, we will have to draw the calcium atom. Then we draw for oxygen atom. That is, we are drawing for their electronic configuration first. So we draw for calcium, which is 2882. So calcium here, we draw for 2, 8, 8, then 2. So 1, 2. Now this is calcium atom. Now this is just, I did this so that you can understand the concept. So you just do it somewhere, then it will guide you to do this or to draw this. Now the next one is what? Oxygen. So we draw for oxygen, which is 2, 6. So we draw for 2 and 6. 1, 2, 1, 2, then 1, 2. So this is oxygen, our normal electronic configuration for oxygen. Now, calcium here is having electronic configuration of 2, 8, 8, 2. That is the normal calcium. So I said this is just here to guide you. So this one is 2, 6. Are you getting it? So this is the normal one. Now the next one is the calcium here is going to donate and this is going to accept. So this calcium is going to donate the last shell. It is going to donate the last shell to oxygen. And the last shell is having a valence electron of how many? 2. It means calcium is going to donate the 2 to oxygen. So we are going to draw for 288. So 2, 8, then 8. So I write 2, 8, 8. So this is calcium. Now calcium donated how many? 2. So 2 plus. Now the 2 is being transferred to what? To oxygen. So you draw for the 2 being transferred to oxygen. So you are now going to get 2, 6. So 6 plus the 2 which is being donated, you get 2, 8. So we are going to draw for 2, 8. 1, 2, then 8. 1, 2, 1, 2. So you're going to get 2, 8. Now, how many did calcium donated? 2. So the oxygen here accepted how many? 2. So you're going to write O2 minus. So it has accepted 2. Now this is what? Oxygen ion. This is calcium ion. So oxygen here is 2, 8. Then calcium here is 2 plus. Now for their name, you are going to get, this is Ca and this is O. So you're going to join the Ca and O. Now, this is 2 plus, this is minus 2. You're going to cancel out. So you're going to get calcium oxide for this. But don't forget, I said we will do the names of the compound. So when we start doing with the names of the compound, you will know how this calcium oxide is formed. So let's take the next example. Then we move on to covalent compounds. So let's take magnesium. And sulfur. Now, magnesium on the periodic table is having an atomic number of what? 12. So this is a symbol for magnesium having an atomic number 12. This is sulfur S having an atomic number of what? 16. Now, Let's write the electronic configuration for magnesium and sulfur. We are saying that first cell takes how many? 2. Second cell takes what? 8. 2 plus 8 is what? 10. How many more is needed to obtain 12? That is 2. So this is the electronic configuration for magnesium. Sulfur. First cell takes how many? 2. Second, 8. 2 plus 8 is what? 10. How many more is needed here? That is 6. So 2 plus 8 is 10 plus 6 is what? 16. So this is the electronic configuration for sulfur. Sulfur. Okay, now let's continue. Now we are saying that magnesium, this is the normal magnesium atom, this is the normal sulfur atom. So we are drawing for the normal magnesium. Now the normal magnesium is having electronic configuration of what? 282. So we are drawing for 282. So 2, 8, then 2. So let me write 2, 8, 2 for magnesium here. Next one is sulfur. Next one is sulfur. So we are going for 286. So 2, 8, 6. 286. So let me write 2, 8, and 6, which is sulfur. This is magnesium atom, this is sulfur atom. So this is the normal one. This is normal magnesium, this is normal sulfur. Now they are now coming to bond. Now when they bond, they are going to do what? A donation and an acceptance. So magnesium is going to donate the 2 to sulfur, and sulfur is going to accept the 2. Now when magnesium donates the 2, it is going to be left with only 2 and 8. When sulfur accepts the 2, we are going to get 2, 8. Accepting the 2 will be plus 2. So we are going to get what? 8. Are you getting it? So let me draw. So we are going to get 2, 8. So I'll draw for 2 and 8. So this is going to donate 2. So 2, 8 for magnesium. Magnesium donated how many? 2 plus. So we are saying that the metal they would donate to form positively charged ions called the cations. Now sulfur is now going to accept how many? Sulfur is going to accept 2. So 6 plus 2, we are going to get 288. So we will now draw for 288. So 2, 8, 8 here. So 2, 8, 8. So this is now S2 minus. It means it has accepted 2. Now we are going to get magnesium here is what? Mg, sulfur is N. So 2, then negative 2, you're going to get Mg as magnesium sulfur. Okay, so let's do the last example on ionic bonds. This is quite different from the ones I've been giving you. So take note of this. Now we have what we call magnesium and chlorine. Now magnesium and chlorine. Now, magnesium and chlorine, when they bond, we are going to get what we call magnesium chloride. Now, magnesium chloride. Magnesium is having a symbol Mg. Chlorine is having a symbol Cl. Now, magnesium on the periodic table is having atomic number 12. Chlorine on the periodic table is having atomic number 17. Now, let's write the electronic configuration of magnesium and chlorine. Magnesium, first cell takes 2, second takes 8. 2 plus 8 is what? 10. How many more is needed to obtain 12? That is 2. Chlorine is 17. First shell takes 2. Second shell takes 8. 2 plus 8 is what? 10. How many more is needed to obtain 17? That is 7. So 287. Now, this means there is what we call a transfer. Magnesium is going to transfer to what? To chlorine. And chlorine here is also going to transfer what we call what? The 1. Is going to accept the 2. Sorry. So magnesium is going to transfer 2 to chlorine, and chlorine is going to what? To accept the 2. Take note. So there is what we call MgCl2 like this, because magnesium here is what? Mg2 plus. I want to explain it for you to understand. Magnesium would donate the 2 to become 2 plus. So Mg2 plus. Now, chlorine here is having a charge of -1. Chlorine is having a charge of -1. So take note. The charge of chlorine here is -1 because 287. How many more is needed for it to be stable? That is 1. Chlorine needs 1 to be stable. 7. Chlorine needs 1 to be stable. Now, they are going to do what we call exchange like this. So, if they exchange, there will be MgCl like this. So, magnesium down, chlorine down. Now, they are going to exchange their numbers. So, magnesium will give the 2 to chlorine. Then chlorine will give the 1 to magnesium like this. So, you are going to get MgCl2 like this. Now, at the same time, let's forget about this. Let's take another example. If I have calcium and oxygen, calcium Ca, oxygen O, which is 2882. So it means it is having an atomic number of what? 20. Oxygen here is having an atomic number of what? 8. So 2, 6. Now look at this. Calcium is going to donate how many? 2 plus. Calcium is going to donate 2. So when you donate the 2, you become positive. Oxygen here is going to accept how many? 2. So O2 minus like this. So oxygen is going to accept 2. So it means oxygen needs 2 to be stable. So we cross them like this, then we get calcium, I write it, oxygen, I write it like this. So this is 2 This is 2. They are going to cancel out. So we are going to get CaO like this. So we are going to get CaO. So this is the same as this one. Just that chlorine here is 1, magnesium here is 2. So we are going to get something like MgCl2 here. So we are going to draw for MgCl2. So we are going to draw for MgCl2 here, which is magnesium and chlorine. Now, let's draw the normal magnesium. Let's draw the normal chlorine. Now, this will help you to do the assignment I give you. Now, magnesium is 2H2, so we are drawing for 2H2, which is magnesium. So 2H2. So let me draw for 2H2, which is magnesium. Now, looking at this, how many chlorine is present here? There is 2 chlorines. Are you getting it? There is 2 chlorine. So you are going to draw chlorine 2. Now chlorine is 2H7. You are going to draw chlorine 2H7 and the chlorine 2H7. So let me draw the first one up, the next one down. So 2 H 7. 1, 2, 1, 2, 1, 2. Left with how many? 1. So it is going to donate 1 to this. Then another chlorine, because it is 2 chlorines are present here. So number of atoms of chlorine is 2. So we are going to draw 2 chlorine. So this is normal chlorine. Another chlorine will come. This is 1, 2. This is 1, 2, 1, 2, 1, 2, 1, 2. Then how many is left? 7. 1, 2, 1, 2, 1, 2, 6. Then 1. So like this. Are you getting it? So this is chlorine 2H7. This is another chlorine 2H7. So there is 1 chlorine here. There is 1 chlorine here. You're going to get 2 chlorines. Are you getting it? So this is the normal one. 2H7, 2H7, 2H2 for magnesium. Then we move on to the next one. So we are going to get now this magnesium here donated how many? 2. Are you getting it? Magnesium is donated 2. So we are going to get 2, 8 now. So Mg2 plus. So we are going to get 2, 8. Are you getting it? Okay, so let's continue. Now, the next one is we drop. Now, don't forget, the 2 here is going to be donated to chlorine. Now, there is 2. You can actually split it, give this one 1 so that it will be stable to get 2, 8, 8. Then you also give this one 1. So you are sharing the 2 to this 2 chlorine. So you can give 1 to this, you give 1 to this, then you get 2, 8, 8 so that this one will be stable. Then you also get 2, 8, 8 so that this one will be stable. Or you draw for only one of the chlorine like this. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, then 1, 2, 1, 2, 1, 2, 1, 2. So this is 288 like this. 288 here like this. Now, since there is two chlorines here, you just do something like this. There is two of the chlorines here like this. So two chlorines here. It means 2 is multiplying chlorine. So there is two chlorines here. Or if you don't want it like this, you just draw this and this. Then you give one to this. Then you give one to this. Then you are going to get 288, 288. Or you draw only one, then you make it two of the chlorines are present here. Like this, 288. You just fill it because it is going to be filled. All right. If you have any issues, now you can leave a comment so that it will be very easy for me to read your comments and your. Now don't forget to subscribe to my channel so that whenever I make a new video, you can get a notification, then you watch the video. Thank you all for joining my class. Now in our next lesson, we will talk about the covalent compounds and their formation, how covalent compounds are also formed. Now, covalent compounds, they also lead to what we call the covalent bonds. So we also do something like this, but it's quite different.